Hello, my name is Claudia Zhang, and for this presentation, I will be talking about the regulation of the gastric phase. But before we go into that, it's important to understand the whole story. There are 3 phases to digestion, and here they are all depicted. The first phase of digestion is the cephalic phase, and in this phase, chemical and mechanical digestion is occurring at the oral cavity, and the oral cavity includes the pharynx and the mouth. Anything that happens between the time before even food was entering the mouth to anything that happens above the stomach would be counted as part of the cephalic phase. And it starts with either a short or a long reflex relating to the vagus nerve for the long reflex, and it could include smelling, seeing, or even thinking about food, which would be part of the long reflex of the phase. The second phase of digestion is the gastric phase, and the gastric phase occurs once the bolus enters the stomach, and the bolus is just another name for food. A series of pathways occurs in our stomach, as we shall see later. And the third phase of digestion is the intestinal phase, and in the intestinal phase, it encompasses digestion in the small and the large intestine. The most digestion of substances actually occurs in the small intestine. And today we'll be focusing on the regulation of the gastric phase. So, the gastric phase occurs in the stomach, and there's 3 functions of the stomach, which includes storage of food to regulate the passage into the small intestine, and a big one is digestion, in which the stomach chemically and mechanically digests food through acids, enzymes, and signal molecules. The last is to protect the GI tracts from bacteria and other pathogens. And on this slide is a graphic of a chart of secretory cells in the stomach that will help to complete its functions. And this graphic was taken from Silverthorne in the digestion chapter. And we'll get into this slide right now. We'll start on the bottom of the graphic. And on the bottom of the graphic, we'll start with G cells. And G cells are used to stimulate gastric acid secretion. And then above that, D cells. D cells are used to regulate this activity when there's enough hydrochloric acid in the stomach. And chief cells are used to break down proteins and fats. Parietal cells help to secrete more hydrochloric acid, as well as complexing with vitamin B12 to allow for absorption. Next we have mucus cells, which are for protection, and I'll get into more of that later. But from this graphic, you can tell that the stomach is lined with a whole bunch of epithelial cells to make this complex network of processes in the stomach, and we'll see how this plays out in the next slide. So this is another graphic taken from Silverthorne, and it shows the integration of the cephalic and the gastric phase. And I'll get into that right now. They kind of blend into one another in this diagram, but there's 2 ways to turn on the stomach. The first way is food enters the stomach through, and it's called a short reflex. And the second way that the stomach can be turned on is when there's input from the vagus nerve, and this relates to the long reflex. So say you're thinking about eating food or thinking about a specific dish, your brain would send information to the stomach to turn it on, since it's part of the cephalic phase. And this is part of the long reflex and relates to the vagus nerve. And both ways start off with stimulating our G cells, as seen here. Our G cells secrete gastrin, and gastrin go on to inform parietal cells to secrete hydrogen ions, which helps with the buildup of hydrochloric acid in the stomach. And the stomach, as we know, is very acidic, and to ensure that it is actually secreting these hydrogen ions as a backup method. Gastrin also stimulates the ECL cell to release histamine, and histamine goes on in the similar process of stimulating the parietal cells to release more hydrogen ions to ensure that the pH of the stomach remains low. And rising stomach levels will stimulate chief cells, as seen down here, to release pepsinogen, and pepsinogen turns into pepsin, and pepsin would digest our proteins. Chief cells will also release gastric lipase to digest our fats. And after the stomach is turned on and it's really acidic, we need a way to regulate it through a negative feedback pathway, as seen here. So after the third step of building up hydrogen ions and allowing it to break down our fats and proteins, we need to regulate the buildup of too much hydrogen atoms, which can contribute to too low of a pH in our stomach levels. And through this negative feedback pathway, we're able to stimulate D cells to release somatostatin. And somatostatin goes on and informs the G cell to stop releasing gastrin, and informs the ECL cell to stop releasing histamine, and tells and inhibits the production of more hydrogen ions, since all the fats and proteins have been broken down. So yeah, this is a good regulatory way to make sure that the pH of the stomach remains at an optimal and a level that makes sense. Fun fact is the pH of the stomach is 2.0. And this is my last slide that depicts gastric, how there is gastric phase protection. And this is because you may be wondering, with hydrochloric acid in our stomach, how does it not end up eating itself up, since it's really acidic? How does it not end up eating up the GI tract? Well, the gastric phase is also protected by mucus cells, as previously mentioned before. And mucus is a bicarbonate barrier that protects the gastric mucosa from autodigestion, otherwise known as eating up the gastrointestinal tract. Mucus cells in the neck of the gastric glands secrete both mucus and bicarbonate, and mucus forms a thick physical barrier between the stomach acid and the capillaries of our GI tract. And this is our first line of defense. If the mucus layer happens to thin out, then we can rely on bicarbonate, which creates a chemical barrier to neutralize acid that bypasses the mucus layer. And this can be seen here. We have the thick mucus layer, which represents the physical barrier, and if gastric juices happen to leak through because of the thin mucus layer, then bicarbonate comes out and neutralizes dangerous pH levels of the acid into something neutral. And if both systems fail, then we may be susceptible to ulcers. Okay, this wraps up our consideration of the gastric phase, and here is my reference. Thank you.